Hey, it's Mr. Allred, and we're going to talk about properties of logarithms. These properties kind of let you combine multiple logs of the same base into a single log, and sometimes they can allow you to get rid of some multipliers or some extra material in front of a logarithm. They're not too hard to use and they're not too hard to remember. It's just that when you do use them, you're probably not thinking about them ahead of time. There is a log version and a natural log version, so there's two of each. But the first one here talks about an addition of two logs. So keep in mind, anytime you see logarithm, that you're really talking about an exponent. So we got log base a of x plus log base a of y. And we want to combine that into a single logarithm, which is the logarithm base a of x times y. So why did these two logs go from being added together, or adding these two exponents, to being multiplied in a single log? Best thing to explain here is they're representative of exponents, as I said. So if we had base a of m plus n in the exponent, where we're actually adding two exponents together, that came from multiplying bases, a to the m times a to the n. Okay? So we can, if we're adding two logarithms together of the same base, now they both have to have the same number down there, base a, we can combine them into one logarithm using multiplication. So the same follows with natural log of x plus natural log of y equals natural log of xy. The next one is a subtraction property. Natural log base a of x minus natural log base a of y equals logarithm a of x over y, or x divided by y. So basically this is the same thing. If we had base a with two exponents subtracted, m minus n, that came from the fraction a to the m over a to the n. So when we divided bases, we subtracted exponents. And likewise, there's a logarithm version, the natural log version, natural log of x minus natural log of y equals the natural log of x over y. The last one's a little bit different. It's r as a coefficient, so r times the log base a of x equals log base a of x to the r. So how does that happen? Well, if you'll remember, when we multiply exponents, so a to the m times n, that's in the exponent, that was a to the m raised to the n. So power to a power, which is what we're doing here, logarithm means exponent, and then we're going to raise it to the r here, was a multiplication. So keeping the rules here that I've highlighted handy are going to be useful when we try to solve equations. Likewise, it has the natural log version, r times natural log of x equals natural log of x to the r. So generally what we're going to do is we're going to use these rules to kind of combine logarithms. So let's just do a little bit of practice of that. So here we have simplify using these properties, and the first example we have is the log of 4x plus the log of 2y minus the log of 8z. Now all of these are understood to be base 10, so they have to be the same base. And anything that has a plus or addition in front of it is going to go into the multiplication mode, and anything with a negative is going to go into the division mode. So all of these, even though there's three things, can be combined into one logarithm. So it'll be log, and we're going to take all the positive ones and put them in the numerator. Okay, 4x times 2y, all the negative ones and put them in the denominator, 8z. So it looks like we'll have 8xy over 8z. So I'm just going to go ahead and combine that and say it's the log of xy over z, since 8 over 8 would divide out. Okay. The next one is base e natural log, but it's 2 times the natural log of x plus 5 times the natural log of y. Now this is addition, so there's going to be some multiplication there. But the problem is, how do you turn that multiplication into something when you have 2 of one thing and 5 of the other. So we're going to use that last property where we move that 2 in as an exponent. So 2 natural log of x will turn into natural log of x squared, plus, and 5 natural log of y will turn into a natural log of y to the 5th. And then we can use that addition to multiplication property where we'll have the natural log of x squared times y to the 5th. So in both of these examples, we went from multiple logs to a single log. Okay. And the nice thing about this is when we get to equations, if you have a single logarithm, then you can use that definition of exponents to rewrite it in an exponential form if useful. But if you have multiple logs in the same equation, it's not as much fun. We'll see it in a little bit. Okay, 2 more examples using these properties. Here is log base 8 of 3 minus 2 times the log base 8 of 4x. Okay, so we do have that subtraction in there. So we know there's going to be some type of division, but we've got to get rid of that 2 first. So we're going to bring that 2 in front of the log base 8 of 4x inside as an exponent. So I'm just going to bring down the first one, log base 8 of 3. And I'm going to leave the minus there. And I'm going to take the 2 in. So it'll be log base 8. And if I square 4x, I'm going to get 16x squared. Okay. I could do it a couple different ways, but that just helps me get rid of that exponent if I want to. I could just say 4x in parentheses squared, but trying to help myself remember that the 4 is getting squared as well. But in that case, I've got 2 logarithms subtracted of the same base. So I'll have log base 8 of 3 on top and 16x squared on the bottom. Okay. So right now we're not at equations, we're just simplifying, combining things. The next one, 2 log base 3 of 8 minus log base 3 of 6 plus log base 3 of 9. Now I do once again have some positives and negatives. I've got quite a few things here. Oop, get the yellow. Got a little slow here. But I do need to get rid of that 2 in front of the first logarithm. So I'm going to go ahead and push it in as an exponent. So this is the R rule we had. So moving that 2 into the first one, I'll have log base 3 of 8 squared. But let's go ahead and make that 64. And I'm just going to copy the other ones down, then I'll combine them. Minus log base 3 of 6 plus log base 3 of 9. So now I'm going to combine them. I'm going to have log base 3 of the positive ones on top, 64. It'll be times 9. And that'll all be over the negative one, which is 6. I know I can reduce that. I don't know if it divides out. Let me pick up a calculator. 64 times 9 is 576, and if I divide that by 6, it looks like I get 96. So log base 3 of 96, which does have its own value since there is no variable in there. But if I set it equal to a z, like in some other videos, and rewrite it as exponential and trying to solve it, there's not a good connection between the 3 and the 96. So I'm just going to stop right there. Alright, so we're going to see how some of these properties help us with the calculator in a little bit.